All right, so as I said before, this week we're going to look at this last section in chapter 10, which is 10.6. It's kind of its own topic, so we're not going to do anything more than what we do today with it. Okay, tomorrow we're going to talk about something new. Okay, but here's an example of direct variation. Okay, so I just want to give you guys kind of a real world example first, and then I think you've seen this kind of stuff before. All right, so this example says Peter earns $20 an hour for playing in a band. So if Peter works for 1 hour, how much money does he make? $20. Makes $20. Okay. What if he works 2 hours? 40. Yeah. So as Peter works more hours, what happens to the amount of money he makes? It increases. Okay. He works more hours, he makes more money. If he works less hours, he makes less money. Okay. That's called a direct variation. Okay. As one thing changes, as the amount of time he works changes, if it goes up, the amount of money he makes changes. It goes up. All right. All right. So the amount of money that he earns is directly related to how many hours he works. Okay? And a lot of jobs are like that. If you get paid by the hour, if you work twice as many hours, you make twice as much money. If you work half as much, you make half the money. All right. So let's look at a formula that would give us how much money he earns as a function of the number of hours he works.
Yeah, this is just an example. Just listen to this. That's why I don't have to write anything.
All right. So if I filled in 1 for a number of hours of work, what's 20 times 1? 20. 20 times 1 would give me an earnings of $20. If we plug in 2 hours, what's 20 times 2? 40. So that would be an earning of $40. If we plug in 5, 20 times 5 would be, 100. Right? So this is a formula, and this is what most of our formulas are going to look like for direct variation. We've got a letter equals a number and a letter. So it's just those 4 things. Letter equals number and letter. And that's it. There's no plus or minus at the end. Not when we're doing direct variation. You guys remember when we had something like this? We had like a +2 or -7 or something on the end like that? You guys remember that? Does anyone remember what this number was called? This was your slope. How about this number at the end? Yeah? Yeah, the y-intercept. So basically today, in every problem, there's no y-intercept. It's not there. Okay? That's direct variation. Okay? And next thing, if I just put this back up for a second. When I graph something like that, what shape is it on paper? Like, is it a curve? How would this look if you draw this? Corey?
I can't remember if it's horizontal.
It's okay if you don't know what direction, but what's the general shape of it?
A straight line.
Yeah, it's a straight line. All right? So direct variation has to do with a line. If you draw it, a picture of it, it would look like a straight line. All right? And there's your formula for direct variation. So this is probably something you want to write down. Okay. Direct variation, it's a linear function, meaning if you draw it, nice straight line.
Space for that on a sheet too.
And it's defined by an equation that looks just like this. Letter equals k will be a number. Okay? Could be 2. In the last problem, it was 20. Okay? Sometimes we have to find the number. And then it ends in a letter. Okay, so here's another example if you want one. Y equals 8x. That's another example of a direct variation equation. Any questions on that? All right, so sometimes what they're going to do is ask us to find this number. Okay? It depends on the problem. this number that I just circled, or what we're calling k, it has a special name. Okay? It's called the constant of variation.
So guys, you have that on your sheet, you have like the K with like an arrow coming out, you're just gonna on that line write constant of variation.
And the reason it's important to know that term is you might have directions in a problem that say, find the constant of variation. So if you don't know what letter that is, you're not going to know what they're asking for. Okay? The constant of variation is k. And notice here I wrote something special. What does this say in parentheses? It says k, what's the symbol? Yeah? Not equal to. K can never be 0. Okay? Your constant of variation can be anything you want except one number. It can't be 0. Okay, so any questions on which letter is the constant of variation? All right. So when we write an equation for direct variation, you might see these directions. Okay, you might even see something like this on the test. It says y varies directly as x. I know it sounds kind of weird the way you read that. But that's how our book pronounces that. Okay, so when you see this sentence, y varies directly as x, I think it would make more sense if you said y varies directly with x. To me, that makes a little more sense. I'll even put that in parentheses. But you might see that sentence in our book, and you'll probably see it on the test. Y varies directly as x. It just means we're doing a direct variation problem. Okay, not everything is direct variation. Here's an example of something that isn't. Okay? The more money that you spend, the less that you have in your savings account. All right? So as spending goes up, money in savings account goes down. Okay? That's not direct variation. As one thing goes up, something else is going down. Direct variation, as one goes up, the other goes up. Or as one goes down, the other goes down. Right? So we're only talking about direct variation. All right, and this is how you find the constant of variation. Okay, what they'll do is they'll give you an x, they'll give you a y, and you plug them in. Okay, you're going to fill in an x value, you're going to fill in a y value, and what's the only letter that I haven't filled in for? Yeah, okay. K. K is the only letter I haven't filled in for, and I'm going to solve for K.
Yeah, you guys are going to see there's going to almost be like two problems. You're going to solve for K first, so you can plug it in to get what it's asking for. It'll make more sense when you see it.
All right, so let's just look at an example. Okay, y varies directly as x. Okay, that's telling me I'm doing a direct variation problem. That's all. All right. So basically, we're doing what I just taught you. Okay, it says y is 45 when x is 9. Find the constant of variation. Okay, let's just start with that. Who can remind me what is my direct variation equation? That has the x, the k, and the y in it. Somebody give me that equation? Yeah. Yep. Y equals k. You can put parentheses or just put y equals kx. Right. Now, Zach, what two letters did they give me in the problem up above? Yeah, they said y is 45, x is 9. All right. So Kevin, what am I going to do with 45? Yeah, we're going to plug it in where the y is. And Victor, what am I going to do with the 9? Well, read that first sentence again. Yeah, it says x is 9. Right? So we're going to fill that in for x, and now we're going to find k. Right? That's the constant of variation. All right, so fill it in. Sam, can you tell me what I get when I fill that in?
45 equals 9K.
Yeah, so what you did is perfect. Whoops, what I did is not. So she said 45 equals 9k. Okay, I had 45 equals k times 9. Well, I just filled it in the order that it was, but if you're more comfortable writing the number first, you can always switch that order. Think about when you multiply two things. 3 times 2, 2 times 3. Doesn't matter the order you multiply. Right? And now I've just got one step to solve for k. Okay, what's nice about these equations is they're always one step. You never have to do more than one step to get k by itself, all day. So how about Ryan? Can you tell me what I do to get k by itself?
You times 9 by a number.
Well, look at what we have here. We've already times 9 by what?
5.
On this right-hand side. What did we multiply 9 by here?
5.
I know what you're getting at. I can kind of see the way you're thinking a little bit, but just pronounce that right-hand side to me.
9k.
And what operation is that?
Multiplication.
Yeah, there we go. So how would you undo multiplication? What's the
Divide.
opposite? Yeah. So you divide by 9. And I think you were already thinking the answer in your head. I know you already got it. What did you get for k?
5.
Yeah. All right, so we get k equals 5. Okay, and what is that? K is, somebody remind me one more time, what's k?
What's it? Constant?
Yeah, this is my constant of variation. Okay, so in this problem, k is 5. But we're not done yet. They asked me to do one more thing. Now they said, find y when x is 7. All right? So now I'm going to take my constant of variation equation. Before it was y equals kx, but we just found out what k is. Hey, somebody, what's k again? 5. Right? So now I'm going to fill that in. Okay? Forget about the original x and y. We're done with them. The only reason we needed them was to find the 5. We've got the 5. So now we've got this. Anybody think they could tell us how to do this last part? Find y when x is 7. Yeah, Rose?
Would you put X in your equation as 7?
Yeah, take the 7, fill it in for x.
And then it's your multiplication. Would you do the opposite, or would you just make it better?
Nope, the letter's already by itself. So this is just like PEMDAS. We just do out arithmetic.
Okay, so you're going to multiply the 5 and 7.
Yes,
to get the answer.
yes. And what do I get? Rose, can you do that out? You know what you get there?
What? Yeah,
Five.
I'm gonna get there. Oh, wait, no, that's 35. How
30.
did I not know that, right?
Good job. All right, so we get y equals 35. Now, why didn't I just do that originally? Why didn't I just take 7, fill it in for x, and figure out y right away? Because what? Be a different answer. All right? Anyway, yeah? Yeah, we didn't have k, right? We couldn't even do the second part of this problem until we do the first part. You got to get k first, and then you can do the second part. All right? So always find your constant of variation first, and then you can answer the second part. All right, so let's try another one of those. Okay. What's this first sentence telling me? It's telling me that I have what kind of problem? Why
Guys,
there's...
just watch this one. You don't have it on your sheet, but just watch it.
What does this tell me? Y varies directly with X. Well, Gage, can you tell me, what is this telling me?
It's with X, like,
How about in 2 words? What kind of problem is this? Can I help them out? Yeah? This is a direct variation problem. If they didn't put this sentence and they just gave you all this information, doesn't mean anything. All right? We can't do what I taught you unless it's a direct variation problem. Right? If it's not, can't solve it. Okay? So we are doing a direct variation problem. And it says y is 18 when x is 27. Okay? Don't even look at the second part yet. All right? That part we can't do. We got to do this first part. Now, they're not guiding me through the problem as much. Okay, the first one they kind of said, find the constant of variation, and they led you through it. This one, they're not doing that. Okay, so your first step is to find the constant of variation, which, Ariana, is which letter?
There's no K.
So which letter is our constant of variation? So our constant of variation, K. Yeah, so we got to find K. All right, Maria, can you remind me what is my equation that I use when I have direct variation?
Y equals K.
Y equals Kx. All right, now Ben, can you fill in what we've got and help us find K?
18 equals K27.
Yep, 18 equals K times 27. All right. Y is 18, X is 27. And Logan, what's my last step to get K by itself?
Divide K27 by 27, so you basically cancel 27.
All right.
And then you divide 18 by 27.
Divide 18 by 27. And I think we can reduce that a little bit. What number goes into both 18 and 27? What do you think? What number? Yeah, Alex?
9.
9, good. 9 times 2 is 18. 9 times 3 is 27. Right, so K is 2/3. All right. Now, are we done, or is there anything else they asked me to do? Yeah, there's one more thing. Victor, what's the last thing they want me to do?
Find x when y is 8.
Find x when y is 8. First thing I'm going to do is rewrite my equation, but now I know K. Right, Gabe, what's K? Yeah, K is 2/3. And now they said find x if you fill in 8 for y. All right, so this one is also just one step, but there's a trick here. Anybody remember how you move a fraction to the other side? You end up multiplying by something. Yeah? Yeah, we're going to multiply by the reciprocal, which means to take this fraction and flip it. All right, so you multiply by 3/2 and 3/2. When I do that on the right, that's gone. Now in the top, Kevin, what's 3 times 8? Yeah. Yep, we get 24. And now, if you can reduce it, always make sure you reduce it. Okay, what's 24 divided by 2? Oh, Ryan? Thinking a half of 24.
11?
That'd be half of, did I say 22?
I think so.
Oh, half of 24, sorry. 11 would be half of 22.
It's 12. Sorry.
12. All right, so we found both things they wanted. There's my constant of variation. And we found x when y is 8. All right, so any questions on that? So you'll definitely on the test have one or two of these types. Okay? Find the constant of variation and then find something else. All right, next type. Sometimes what they're going to do is give us a table. Okay? They'll give us a bunch of ordered pairs, okay? Kind of like we had on the test. But instead of asking us if the table is a function, okay, that's what we did before, they're going to ask us a different question about the table. They're going to ask us if the table represents direct variation. Okay? Here's how you figure it out. You look at your table. If you take y and divide by x, and it always comes out the same for every row in your table, then you have direct variation. All right, so if you take y, divide by x, and it always comes out the same, then you have direct variation. Okay. Does anybody have any question on that? Yeah?
Where do you write that in here? Like, are we writing that down? Where does it write it in?
I would put it somewhere. It is important to know how you do it.
You guys got a little space on that, says when given a table of ordered pairs, use. So you have that line, so you're going to put y over x, and then in the box, it says you're going to write constant. It's almost like right what Mr. Hager has. Because you already have that fraction line on your sheet. So y over x equals, then in the box, you're just going to write constant.
Okay, so this is the second type of problem. I think this one's a little easier than the last one. All we have to do is use our calculator, or if we can do it in our head, check division. Okay, we don't have to actually solve any equations this time. Okay, does everybody have what's in that box? Good? All right. So, it says from the table below, determine if y varies directly with x. All right. Gage, what does that mean? Y varies directly with x.
Direct variation.
Right. All they're asking us here, good job, is if this is a direct variation. Don't be confused by that sentence. From the table, determine if you have direct variation. If we do, find the constant. Well, you guys got a formula on the last page to find the constant. If it comes out the same when you divide every time, that's our constant. All right, so Logan, what's the formula to find the constant?
Y over x equals
Y over x. Okay, let's check it for the first row. Okay, Davin, in the first row, what's y divided by x?
26. Wait, like,
If
divide?
you do out negative 12 divided by positive 2.
I don't know.
Well, start with what's a negative divided by a positive?
Positive.
You want to help them out? What's our rule for that?
I don't know stuff.
Negative divided by positive?
It's always a negative.
Always a negative, yeah. And now just focus on the numbers. What's 12 divided by 2?
6.
6. Okay, so negative 6. All right, so you were close the first time, we just had to make it negative. All right, let's check the next one. Y divided by x. Okay, y is negative 30. X is 5. Okay, Caitlin, what's negative 30 divided by 5? Yeah, negative 6. Okay, we're hoping we get that same number all the way through. If we do, this is direct variation. If we don't, it's not. Right, and how about rows? What am I going to do for that last row in the table?
You're gonna put 12 over
Yep, we're going to do 12 over negative 2. And can you tell me what 12 divided by negative 2 is? Negative 6. All right, so Corey, did we get the same thing every time? So the answer to this question, determine if we have direct variation. We can write yes. This is direct variation. We just abbreviate DV, direct variation. Now it said if we had direct variation, find the constant. Okay, what's the constant here? Negative 6. All right. Any questions on that one? All right, so a little bit easier than the last type. You don't have to do any algebra. Just got to do some arithmetic. Okay, why don't you guys try this one on your own?
It's on the back. It's on the back side.
Okay, same directions. Determine if you have direct variation. And if you do, find the constant. If you don't, there's no constant to find. All right, so just take a second and give that a shot. All right, so my first row in the table. Justin, what do I divide in this first row?
36.
That's it. And what's 36 divided by 6? 6. Okay. Can I answer if it's direct variation just checking the first row? No. I got to check and make sure they all match. Okay. So to check that it is direct variation, you got to make sure every row matches. To see if it's not, we just have to find one row that's different. Okay. If we find a row that's different, we're done. Okay. My next row. Sam, what do I check here? All right, 64 divided by 8. Okay. What's 64 divided by 8? Michaela? 8. Do I need to keep going? No. Because I got a different number. What does that mean about this table?
That is not a direct variation.
This is not direct variation. Okay, not direct variation. So do I need to find the constant? No, there isn't one. If it's not direct variation, there's no constant to find. Okay?
Yeah, that's all you're doing. Guys, you don't have this. You don't have this one on your sheet. It's just a different way to think about it.
Yeah, this one, basically instead of writing it in a table, they just listed the points out horizontally. Okay? But I just want you guys to be comfortable seeing it different ways. Okay? So in this first point, how would I check for direct variation? What would I do?
5
Yep.
by negative 3.
5 divided by negative 3. I can't reduce it. Just leave it. Okay? How about the next one? What would I do?
Negative 10 divided by 6.
Negative 10 divided by 6. Now that one does reduce. What number goes into the top and the bottom? Caitlin? 2. So that becomes negative 5 over 3. Is that the same thing as 5 over negative 3?
Yes.
Yeah. So far we got 2 that are the same. Can I stop and say, yep, direct variation? No. Got to check them all. Okay. Ben, what's my last one?
Negative 15 and 25.
So what goes on top?
Negative 15.
Y goes on top. Yep.
I meant 25 negative 15.
There you go. Okay, and what number is the top and bottom divisible by? 5. 5 goes into 25 5 times. 5 goes into 15 negative 15, something, negative 3. So do I have direct variation here? What do you think, Ryan? Do I have direct variation here?
Yes.
Yeah. Okay, 5 over 3, and it's negative. 5 over 3, it's negative. 5 over 3, and it's negative. They all came out the same.
Does 3 have to be negative for it to be?
Nope,
It's the same thing.
doesn't matter if it's in the top or the bottom.
It's still negative.
Ryan, whether you write it like this, let me slow down, or like this,
All the same.
whether you put it in the top, the bottom, or put it right in the middle, it's all the same. The only reason I don't like to put it in the middle is because sometimes when people put a negative right in the middle, they draw the line like that, and then I can't tell if it's part of the division line or they actually meant negative. So if you're going to put a negative, it's better to put it in the top or the bottom. Okay, any questions on that one? All right, so if we have direct variation, we can set up word problems. All right, as long as we have a direct variation, we can use proportions to solve them. And you guys have already done these kinds of problems before. All right, so we'll take a look at a couple of these. Mr. Roy is going to help you set them up. Keep in mind, anytime you set up a proportion, there's always more than one way to do it. There's a bunch of ways. So if you're thinking something different in your head as Mr. Roy goes through it, you might be right. Okay?
All right, guys. So it says on your sheet, right? It says blank can also be used to solve word problems with direct variation. What are we going to use? Proportions, right? So you're going to fill in that blank with the word proportions. Use a different color so you guys can see a little bit better. All right, so we're going to use proportions. So on your sheet, you have a thing that says set up, then you have a couple, like an equal sign with a couple fraction bars. We're going to fill that in right now. This is, and like Mr. Hager said, there's a lot of ways to set these up, right? To set up these different proportions. The way I do it, so it's consistent, and I can kind of follow like an order, this is what I do. So in your problem, you're going to be given some type of unit of measure. You might be given miles per hour. You might be given hours. You might be given whatever. There's all different units. All right. So I like to do is unit 1. Maybe it's hours. Maybe it's when I set this up, this is going to come. When we go over, it's going to make more sense. That's going to come from the first part of the problem. Usually the first part of that problem, you're going to get unit 1 and unit 2. You might get miles per hour and hours. Right? You might get amps and volts. You might get whatever kind of unit of measure it is. So we get unit 1 over unit 2. And this comes usually from the, let me look at it here. Yeah. This comes from the first usually comes from in the first sentence. You're going to be given both type of units you're going to be dealing with in your problem. We're going to do it in the second sentence. Same thing. Match up your units. Whatever unit 1 was, put it directly across from unit 1 over here. Whatever unit 2 was, you're going to put that across from what you had in the beginning. So if you have hours on top over here, you better have hours on top over here. If you have miles per hour down here, you better have miles per hour down here. One of these you're not going to know. Right, so let's say find miles per hour when it traveled for 8 hours. So one of these 2 units will be unknown. But we're following that same order. Like I said, if you have hours on top in the beginning, you better have hours on top over here. I'll leave that up for a second so you guys can get it down. It might seem a little weird right now, like, oh, I'm not sure, I'm a little confused. Once we go through a problem, like we're gonna go through that first example with the plane, it'll make more sense. Everybody good with this? You guys good? A few more seconds to get that down. And you can use any variable you want. I usually use, Mr. Hager usually uses X. You can use Y, you can use any letter you want. All right? So guys, if I need to come back to this, I will. So, you guys have this on your sheet. So, this first part here, the distance d that a plane travels directly varies with time it has been traveling, provided speed is a constant. All right, so you guys have something that kind of looks, you just have this. Let's send the paper one more time. You just have that. If a plane travels 26,000 miles in 4 hours, how far does it travel in 6 hours? So in our first sentence, well, it wasn't a sentence, but up until the comma there. What's one unit that I have? Ryan?
Hours.
Okay. I'm going to put, because it's mentioned second, I'm going to put it down here. I have hours. What's my other unit that I have in that problem in the beginning? What else do I have besides hours? Miles, right? I'm going to put miles on top. If you did hours up top and miles on the bottom, you're not wrong. I'm just going to do miles on the top because it's the first thing that's in the problem. I got miles here. What am I going to set up again? What am I setting up? What's it called? Proportion, right? So I'm going to have a fraction bar, equal sign, another fraction bar. So miles, what's going to go here? Who can tell me by raising their hand? Corey? 2,600, right? That's miles. It's the first thing that's mentioned, so I'm going to put it there. I got hours on the bottom. All right, so Davin, what number is going to go here? 4. Miles over hours. I'm going to do the same thing over here. I'm going to do miles over hours again. All right, so how far does it travel in 6 hours? Am I going to put a number here on the top or a number on the bottom? Bottom, right? Because I'm putting what on the bottom again? Hours, right? So I'm going to put my 6 on the bottom. That's where my hours go. I'm going to put 6 here. What about on top? Right? X. I mean, it said if I go back up to the top, it said I could use D. If you use X, you're not wrong. A lot of times on the test, we won't tell you what letter to use. You want to use X, you're not wrong. You're still going to fall to the same answer. So, but I'm going to use X. We could use D. It doesn't matter. Now, we did proportions a couple weeks ago. To solve a proportion, what do I do? Who can tell me? I'm raising my hand. Okay. Cross multiply, right? So what am I going to multiply? What two things? Anybody tell me? Yep. 2,600 times what? Times 6, right? I'm multiplying this way. Guys, you don't have to do this. You can just do it right out. I'm just going to show you how it works so you can see it visually. Equals, on the other side, Maria, what am I going to have? 4 times x, right? 4 times x. So 4 times x is just going to be what? 4x. Calculator. Stay, where's the calculator?
5th button to the right on the bottom.
Oh, there it is. So I'm going to do 26. 1, 2, 3. Oops, too many. Why clear this thing? There we go. Times 6 equals. Right, so I got 15,600. What's the last thing that I have to do to get my answer? Who knows? Gage, what am I going to do to solve this?
You have to do 2,600 times 6.
I did that. I did 2,006. I got 15,600. What am I gonna do now?
Oh,
Can I
the,
answer
Hold
that?
on.
to divide 4.
Divided by 4, right? I'm gonna divide that by 4. So let me go back to the calculator. I'm gonna divide that by 4 equals 3,900. 3,900 what? Miles, right? So I'm solving for miles in this one. Make sure you label. Right, this is gonna be miles. So 3,900 miles. So again, for these guys, you're setting up your proportions. Stuff that you've done before, right? We have another, everybody has this? Everybody good with this? All right, let's try the next one. All right, so the number of parts a machine can make varies directly with how long it has been running. Machine can make 1,275 parts in 2 hours. How many can it make in 7 hours? What are the 2 things they give me? Kevin, what's one thing that they give me? What's 1 unit? Hours. Hours is 1. All right, I'm going to put that on the bottom because it's second. What else do we have? Huh? Parts, right? Good, Zach. I got parts and I got hours. Same thing as the last one. Fraction bar equals that. What's my parts? Who can tell me? Raise your hand. What's the parts? Ryan?
1,270.
Awesome. Thanks, buddy. 1,275. How about Victor? What about hours? Two. Thanks, Gabe.
What?
Said thank you. Gabe, you told him, right?
I told.
Oh, you told him. Yeah, sorry. All right, so 1,275 over 2. Now, over here, what's going to be my unknown? Jay, what's going to be my unknown? My parts or my hours?
Your part.
My parts, right? So will it be on the top or the bottom? Top. I'm just going to put X. You okay with that? I'm going to put X. On the bottom is going to be what?
7 hours.
Good. Good, Michaela. There it is. What do I do now? I'm not going to write the whole thing out this time. What's one thing I have to do? Cross multiply. So on one side, I'm going to get what? What's the easy one? 2x, right? That's the easy one. I don't need a calculator for that. For the second one, I do. I got to do.
8,900.
You already got it?
Yeah.
1,275 times what again? 7 equals 8,925. Last step.
Divide by 2.
Divide by 2. Good.
4,462 parts.
Say it again, Corey.
4,462 parts.
Nice job labeling it. So x equals 4,462 parts.
Corey, when you did that one, did you get a decimal?
For X,
Yeah, when you did 8925 divided by 2.
after the 2, I got it.
You got a decimal?
Yeah. 0.5.
Right. And you rounded down, which actually that is correct there. Because normally if we have a 5 or higher, what do?
Round.
We usually round up. But if a machine can't make a whole part, then it's only a fraction of a part. We say, you know what, it just can't make that part in that time.
Winning.
So you rounded correct.
Good.
Mm.
So everybody has this, right? Tonight, like I said, is we're doing Groundhog Day here. You have worksheet. I think there's 7 problems. Ms. Vegas is getting this on the video right now. That's why I'm saying it again. There's like 2 y varies directly as x. There's 3 or 4 word problems, and there's 1 where you're given a table and you do the y over x. If they all come out the same, you have direct variation. All right?